Hello, my name is Tomi from TL Lab, and we are in Ruža Bošković Institute in Zagreb, Croatia. My host today will be Doctor of Science Milivoj Urović from Laboratory for Nuclear Physics.
Hello. We are today at the Van de Graaff accelerator facility here at our institute. The accelerator is mainly for producing high energy particles which serve rather different applications and fundamental research in physics. So we are going to take a tour and present to you parts of the accelerator with some technical details.
Thank you, Mr. Urović.
You're welcome. So the first piece of equipment that is needed for the accelerator is the ion source here behind me. In order to accelerate particles, we use electric fields, and to manipulate them, magnetic fields. For a particle to feel the fields, it has to be charged. So depending on the purpose, we have three different ion sources which produce negatively charged ions, which are then accelerated down the tube into the accelerator. In the middle of the accelerator is the high voltage terminal. The voltage here, about 5 million volts, serves to attract the negatively charged ions and strip them of the electrons inside. So our negatively charged ions become positive, and then they are additionally repelled by the same high voltage terminal through the rest of the tube. Here you can see millions of volts for charging the terminal. That's the main source for accelerating. At the end of the accelerator is an analyzing magnet behind me. It can be thought of as a curve of 90 degrees, and different particles with different charge to mass ratio behave differently in this curve. That enables us to separate just the particles that we need from the beam. The beam is usually a cocktail of particles, but this analysis enables us to very fine-tune which beam of which specific energy we want to produce. Then they go later down the tube. Behind me is a switching magnet, which enables us to insert the produced beam into one of the 5 analyzing lines. Depending on the purpose of the measurement and the apparatus we want at the end of the line, we steer the beam into one of these 5 lines, depending on the switching magnet setting. The first of the lines is microprobe. It enables us to focus the beam with a micrometer precision. That is routinely used for examining spatial context of a sample, or to measure the response of the detector depending on which part of the detector the beam hits. So sometimes we analyze the interstrip regions, the border regions of either sample or detector, for which we need such a micrometer precision. The next line is the nuclear scattering chamber, in which we put so-called targets, thin films of known material, where the incoming beam produces by nuclear reactions new elements. These elements are detected on both sides of the beam, and the analysis shows the rate, the energies, and the excited levels of nuclei that are formed in these reactions. Nuclear reactions don't occur naturally on Earth, but here we can model or measure events that take place in other environments, like interiors of the stars and sun, where new elements are produced. This is the time of flight and elastic recoil line, which enables us to measure the recoils from an unknown sample here. And this leg here measures time of flight both with the incoming energy of the particle that is routinely used for identification. And with elastic recoil, you basically analyze what sorts of atoms are present in your specimen. So you can think of it as a billiards, as a pool with nuclei instead of small balls. And our incoming beam just scatters the material in the target, and thus enables us to analyze what sort of atoms are present. Unlike chemical analysis, this usually just numbers different atoms and even isotopes. So it's rather useful as a non-chemist and non-destructive method of chemical analysis. This is the small Van de Graaff accelerator machine. We use it alternatively with the big one, depending on what type of beam and what energy we need. Unlike the big one that has a terminal voltage of 5 million volts, this one goes up to 1 million, but it is very compact and much easier to handle. So it's a good combination to have two possibilities for different types of measurements.
So thank you, Mr. Ulrich, for presentation of equipment and facility.
You're welcome. It was my pleasure.
Thank you. Goodbye.